what you say.
Hello, internet.
Software and game development. So let's change the title. So the title is gonna be debugging our stack-based VM in Objective-C. There we
Man,
go.
I'm still kind of bummed that like we have to push references into the stack. We can't just have a stack of longs or whatever. That would make life so much easier.
Wait, I didn't follow. What was your complaint?
Like it would be so much easier if we had just a stack of longs instead of a stack of objects. Because this is a VM, right? We are not actually using Objective-C objects as objects in our VM. It's just a flat memory address with integers in it. So it would be better if we could do a stack of integers.
Wait, we are using objects, man. We are using pointers to objects, as far as I understand.
Yes, but my point is we don't actually need that. If
No, it's
you
not
were
about
writing this.
needing. Nobody's talking about needing.
Yeah, no, but I mean, it would be nicer if it was an actual stack of integers instead of a stack of
Okay, so for
pointers.
so for some random reason, Mageta changed the name of this. I have no idea why, and that is kind of against C's convention.
And now
Undefined
we have
reference to instructional p-fetch. Um, okay, so there are imports and includes.
include
What the heck
opcode.
is
It
the
should be
difference,
an
man?
include is from vanilla C,
Yeah,
and it
that I
just
know.
and it just literally splices the text of the header in there. Import is kind of the same thing, but it actually checks if we imported that file already, and if we did, it doesn't do anything. So it's kind of deduplicates like that.
Okay, we gotta discover why it's not finding our stuff. That's all we gotta do. So the line that we are running is this one. So let's ignore all the flags. And we're gonna make a makefile with all of these, or a gist file, whatever. What really matters. Oh, I know what matters. We need you to provide the files as well. Okay, that makes sense. So instructions.
There we go.
Did you get an error? Because the errors go to in the beginning for some random freaking reason.
Apparently
Uh,
not.
okay, so something happened. So can we run stuff? Yes. Okay. We did buy PC register. Hmm? Hmm?
So yeah, we're actually going into the implementation of the call instruction.
Yeah. So let's
So
go
why
there
is
then.
it not calling? Like
Wait. Let's read. Let's read. It's a very powerful ability, the ability to read. Uh,
it is, it's called Yomi in Japanese, and it means the ability to predict what your opponent is going to do and then reacting it before they do it. It is indeed very powerful.
okay, I actually want to make a function. Not a function actually. Actually a VM method. Whew, so we're gonna make a function, well, a method, which is gonna be print state. We're gonna go to the VM. Where the heck is clear? Clear code. Thank you very much, sir. And we're gonna make a function that will help us immensely, which will basically do ns log of something. So how the heck we do that again? I already forgot. So at and then the
Um,
thing. So how does that work? Can we just do this? Do you remember?
I have no idea. I'm
Ah,
not an
great.
Objective-C programmer.
Okay, so
I
let's search
mean,
it.
technically, we shouldn't need to put the at in front of the data stack because it's already an object.
Okay, so let's just screw it and let's just do this. Call. After all of that, we're gonna do. How the heck you call a method, man? I always forget this. Oh, here. So you basically pass through it. We passing the argument. Okay, so it's basically brackets. So I believe it's gonna
Bracket.
be something like print state, right?
That should work, I think. I'm not sure if you have to put an explicit self in there or this or whatever, but
So some things are wrong, and that's not how you print. Format string is
oh
not
right,
string literal.
the first value has to be a string like printf, you know.
Oh, so this is the mask. Yeah, but then how are we gonna do that? Which mask I put here?
Well, first of all, you have to put the at in front of the string because it's a string literal and it has to
Mhm.
be turned into an object.
Mhm.
And then for the actual mass, I don't know actually. It would be
How
very
nice.
helpful.
Okay, so how to print
Um,
an array? Objective C. Print. Thank you very much. Okay, it's this. Thank you, internet. This is the mask. Okay, again.
uh,
Next. Use of undeclared identifier. So did I save this? Yes, I did save it. Um, that's okay. Use of an undeclared identifier. So we have pop, right? We do have pop. How are we calling this in main?
um,
Um,
VM new, VM executes.
yeah, but that's not really what we want, right? So how the heck? Oh, self. Okay, so you're right.
Oh, I see.
Print state self. Okay. Do you have any errors? We should suppress these warnings as well. But I already add this thing and didn't do anything. Yeah. See? Does the order matter? Do you think?
There's a WO right in front of it, so probably.
Oh, the order does matter.
I mean, I don't really know because I don't usually compile C code, but seeing as there's a dash W all right after that one, and it is printing the.
Oh, it's useless. It's completely and utterly useless. Um, Not great. Not great at all.
Not great. But I mean, that does tell us that we are reaching the end of the call instruction.
Oh, wait a second. Actually, maybe we are dumb. Yeah, we are dumb because this is a stack, my man. That means that we need a way to print a stack. Okay. So void. This will also have a print stack, and then in here, this is an array now, which
It
means
is.
which means that we can just quite literally put void print state, and we're gonna do.
I think it's called print stack in the header that you wrote.
Yeah, that's true. Oops. Then we're gonna do that, that, that.
You'll probably want to pass the R field instead.
Yes, 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 yes. And then in the VM implementation, when you actually print a state, instead of doing this, you're gonna do data, and you're gonna call print stack.
We should probably also print the
No, we're gonna
the.
print all of them. We're just testing if this works.
Okay.
And the answer is
Well, the stack is empty apparently, so that checks out. Try
okay.
to print the return stack as well. That should do something, I think.
What are the registers? Well, the register is an NS map table, so I'm actually curious what the heck this is gonna print. NS log, NS log, and then we have this thing,
Percent at
and then we're gonna do registers, and I believe we're gonna do, oops, we're gonna use something really similar to memory RAM. Let's see if this compiles. Is there any
apparently it
errors?
does.
No, but it is stupid. So we need to check. We need to check in the beginning.
Okay.
That is quite a series of things to understand. So
All right.
apparently we cannot. Okay, so how to print NS map table objectives C. Okay, thank you very much, sir.
Well, the RAM looks to be correct
The
at
RAM.
first glance. Yes.
I have no idea. This is how the heck we're gonna decode this. Let's actually do that. That sounds fun. So we actually gonna also have to use the the other thing. So control. Let's go to opcode. Yes. So oh fuck us, man. This would be a lot easier if we have the numbers. Do you want to add the numbers?
Technically, it should be in order starting from zero. So,
No,
like
that part
putting
I
that to zero,
understand, but
and then
let's actually do the math between 8 and some everybody else. So let's go. So first thing that we are pushing is a word called opcall. Opcall is one of the last ones.
actually it's one
No.
of the first ones because it's a control flow
Yeah, so it's
instruction.
number 4. 1, 2, 3, 4. It's a number 4. So it's already wrong because this is a number 5.
Well, no, because that's written in decimal, and then four will be it will be encoded uh, as a 5-bit binary number, and then it will be pushed all the way to the left, the very top of
But then
the
we are
the.
completely screwed. So then how the heck are we gonna decode this sort of thing, man?
That's a good question. That's a very good question.
Actually, oh, pack a word. That's how we are doing the crazy thing.
It is.
What is halt? Halt.
Uh,
We have half.
no,
Is
we have halt as well. It's also a control flow instruction. Should be near the beginning.
oh yeah,
For some
15.
reason, yeah, for some reason the comment for stack manipulation is before it, but it's technically a control flow instruction.
Okay, so this is halt is 14. So 14 is basically 6, right? 6. 6 in 5 bits, right? Holy mother. How the heck are we gonna
It's 100, 100, 101. No, actually that's 5. It's 110.
Yeah, but I want to understand. How is this 5 here? My understanding it is picking the 5
Uh,
bits from this
you
and
were
the 5
mixing
bits from
bases.
this
You
and
were mixing
combining
the
them.
you were mixing the bases, Lemos. When you multiply by 10, you just had a 0 if you're working in base 10, right?
Yeah,
And that's basically shifting to the left in base 10.
yeah.
But we're actually shifting in base 2, which means we're multiplying by 2 rather than 10. And because we are shifting 5 bits, we are actually multiplying by 32 instead of 10.
No, that doesn't. I don't care about that. What I care is which bits form this number 5. I don't care if they're being shifted, right? So
Uh,
Because we gotta make sense out of this, right? We gotta try.
Okay, let's see. Let me close this. Let me close this. I'm not using it for the moment. Clear the terminal, and then I'm going to spin up bracket, load bracket, and then let's see.
Oh,
Hash
there is a
D.
print. There is a print. Let's go back. So the registers, right? Yeah, the registers. So it's not like that. So the guy's doing here. So you're basically gonna call another thing, and you're gonna pass that to something called all objects, apparently.
Apparently, okay.
And it 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 got, well, it disappeared. What?
It threw an exception actually.
No, does
It
not
was caught by
recognize
C++.
all objects.
It was caught by C++ apparently.
Oh, here it is. Oh, okay, so there's another thing before that. Okay, so I was looking at the hash map. This is not a hash map. This is a hash table. This is a map table. So you gotta do this first. Key enumerator.
But then we will only see the keys, right? Not the actual values.
I don't know. You're probably correct with that though. Yes, yes. So how can we see the other things? Okay, so yeah, the guy is actually saying keys here.
I mean, there should be a value enumerator as well, right? We can just print it on another line, I think.
That's kind of meh, but okay. So you're saying value enumerator.
I'm not sure if that's the
No
correct name,
docs. No
but
docs. No docs. Who? No docs.
it compiled.
Oh no, but value enumerator only recognize selector sent or to instance. Okay, so not so easy. Not so easy. Okay,
Maybe
so there
object
is an
enumerator. I don't
An
know.
Apple page on that though. There is an Apple page. Let me go to the Apple page.
Yeah, my next guess would be object enumerator.
Where the heck is the thing? What was you just said?
My next guess would be object
You are
enumerator.
right, my friends. Congrats. That's gonna be really hard to debug. Yeah, they have garbage. Well, apparently the 3 is
Uh,
correct. And this number here, oh, he's not similar to this number here, actually.
I mean, it shouldn't be because we're shifting to the left by 5 bits. So yeah.
Okay, let's go. Uh,
um,
let's go back to Emacs. Okay, so we're not gonna try to make sense out of this then. Okay, so let's not try that. But this function is gonna be useful anyway because of the data stack and stuff like that. We should discover how to print these two things though together. We should.
we should. It would be very helpful.
Yeah. Ah boy. Uh, okay, let me.
Anyways, we did run the call instruction, but then for some reason, I wonder. Chime, shell,
What the fuck?
and then of course I have to do
Okay, I have no idea
this.
what happened. My lights went
What?
off, and I thought I lost energy, but you were still here.
That's very weird.
Okay.
It's mysterious.
Okay, so let's hope this is only the only case. Okay, so let's not try to make sense out of these numbers because that's really unproductive. We could, though, try to print word 0 and see what the heck happens, but I don't think that's gonna do anything. I really think this is the result out of the pack. But we should verify that this is correct. Have we done that?
One moment. instruction stack push. Oh, I think I see the problem actually. Is that correct? No, it's not.
No, it's not
Huh.
correct.
No, I'm trying to look at things and let's see. We grab the value of PC, we push it to the return stack.
Wait, where are you looking
We
at?
I'm looking at lines 219, the call instruction
No, no, no.
basically.
But you're not listening to me. We shouldn't do that. What we should
But
do.
I think I see the problem. The problem is we're forgetting to set the ISR register to 0
No, we should do that.
when we do a call. Yes,
Okay, so we do that after setting the PC.
yes, we do that after setting the PC.
Okay, so let's copy this ISR. And we're gonna put
Uh,
the value 0 there, I believe. Is that how we should do that? I don't recall at all.
it should be
At
at zero
at
at
0.
zero.
Okay, it happened again. Can you? Okay, so my lights. What the
I'm
fuck?
still here.
Yeah,
I'm still here.
yeah. The stream is still going as well.
There we go.
We can't make sense out of this though. Well, we can try based on the data stack. Let's actually give it names because that's really unreadable.
It
So
is.
let's
It
say
really is.
fuck.
Go inside print stack and then
No, I don't, I
make
don't.
it.
I don't want to add the semantics to the stack. I want to add the semantics here because this is the only place that makes sense. Um, so let's say data stack. Let's do the same with the return stack. Can you hear me?
I can hear you.
Okay,
No
it's still
problem.
happening. I have no idea why. Registers, names, keys, registers, values, and then this is gonna be the
RAM.
RAM. There we go. So the data stack starts with basically. So how do we print without adding a new line? Do you know?
I don't know.
ns log without.
I mean, this is Objective C, right? Technically, we could just call printf and it should work. But then it wouldn't agree with the formatting of the other lines. So I
Yeah,
don't
the
know.
Stack Overflow guy saying you can use printf. Okay, so apparently this isn't a thing. People are not doing that. Yeah, the best solution is to implement yourself using printf. How useless. How the heck are you? What are you guys talking about? Anyway,
One
uh,
moment. We do a call first. Uh, Open the
oops.
log, please.
Yeah,
Yeah,
there.
that. Okay. So we are doing the call. It's actually working, and then we fetch the instructions at the call. At the point we do the call, right? And then we do calling. Oh, but we're actually printing. Wait a moment. We printed the stuff, which with the print call is in the call instruction, right?
Wait a second, man. Where is this three here? Oh, it's here. No, no, it's here. Sorry. Then we put two words. That's okay. Then we have 3, 4, 5, 2, 2, 2. Okay. Then we're gonna do our first instruction, which is a PC fetch. Is that right?
Yes, whenever we do a call, we set the ISR to 0, which means we do a PC fetch to fetch the first instruction of the
Yes, that
function.
makes sense. So we do the PC fetch, which means that we are basically putting this into the PC, right?
Uh, yes, we're actually putting the words tree into the PC.
Word 3? What?
We start at word 0 because we set the PC to 0 before we
Yeah.
call evaluate.
Yeah.
Then we call 3, which means we put the word 3
Yeah.
as the address that we're jumping into.
Yeah.
And then we set the ISR to 0, which means we fetch the words at address 3, which is word 3, just converted to a number.
Okay, so that
And
means that you're
then,
gonna do another call, right?
no, that means we're going to do 3 fetches first,
3 fetches
and
first.
then we do the call.
Each fetch
After we do the
picks
call,
the values out of memory and put them in the data stack.
yeah,
Okay, so
so
this
the
explains
fetches are
this.
not, yeah, the fetches are not being printed. I think we forgot to log that, but they are happening as you can see in the data stack, right?
Yeah. Okay, then we do another OP call. So we should see calling again. Oh no, we are seeing calling again. This is the first one. I'm blind. This is the second call actually.
Yes, and
Okay.
then
Okay, so the op call we use the I forgot what the heck it uses the next to number, right?
yes,
Okay, so it's gonna pick number
whatever
3 again.
it's gonna pick number. No, that's the fetch. The fetch grabs that number
Oh,
3.
number 2, sorry.
It's gonna grab number 2,
So word
which is a
2,
plus.
which is a plus, which you are not doing, and that's wrong.
We're not logging it, but I think we should.
Okay, let's do that. Actually, I think you guys are not logging any. Yeah, you guys are not logging any of them. Okay. So let's do the following. Oops. What the heck
I
is happening?
mean,
My Control D. Oh, I see. I did Control F, right? No, I'm using Control D. What the heck is wrong? Okay, my shortcut is not working for some reason. Okay, let's for now only do the ones that we care. Later on we can fix. And the indentation is wrong as well. Plus.
plus.
Okay. Okay. So when we do the second call, right? This call here, this call here, right?
We should do a plus, yes.
We should do a plus. Why are we doing PC fetch again?
Because we did a call, which means we have to grab the code of the function we're calling,
Oh, so we need to fulfill PC. That makes sense.
which means we then do a plus, which is what the function does.
Yes.
Then we return.
Wait. We should actually do a print of the state in the plus after the plus.
Uh,
Yes. Self print state. Okay. So yeah, you're grabbing the 4 and the 9, doing a sum, putting that back. Okay. So
then the
when
returns.
returning, we should also do that. Do a print state. It is there, here. After the else, we do that. Okay. That makes a lot of sense, huh? Because we are doing a plus, put that in the data stack, and we are using the 7 to go back, right? And then it
Yes.
vanished from here.
And then for some reason, the register values are empty afterwards. That's
Yeah.
that's not something that should happen.
Wait, before that, let's try to evaluate if this 7 makes sense. So when you do, this happens when you do a call. So when you do a
When you
call,
do a call.
you need to save something apparently.
Yes,
So
you do.
what the fuck are we saving?
We
Return
have to
stack value
save
of PC.
the value of PC. Yes.
But PC is at value 3, right? Why are we
Um,
saving 7?
because we did the fetches beforehand, they step the PC forward so we don't execute data.
Oh, so 4, 5, 6, and then 7.
7 is the next, yes.
Ah. Wait, let me try to recap this. So where are we pushing and doing a PC fetch? Here?
Yes.
Ah.
Um,
Wait,
so
but that
we
doesn't make
call,
sense.
why?
Why? Because we did an OP call, right? Which means that this is only happening in the scope of this function, right?
The first call is pushing the 1 to the return stack right at the top of the log.
Wait, oh, this one.
Yes,
Oh. Oh, oh, okay, 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 okay. Uh, wait, then why are we saving 7? I'm still confused. Wait a second.
because
Uh,
we call 3, right? And then 3 does 3 fetches. So initially the PC after we call 3 should be pointing to, oh, it will be pointing to 3, but then we immediately do the PC fetch, which advances it
four,
to
five, six.
4, and then we do 3 fetches, so 4, 5, 6, 7.
I'm gonna ask you to repeat this. So after
Right.
we do the OP call, we save 1 in the return stack. Is that right?
Yes, that's the previous PC.
Yes, that makes sense. My question is, when you do that, we're gonna jump to 3, which is gonna jump to word 3, right?
Yes, and then what's gonna happen is we're
At
going
this
to
point
fill.
here, at in my of my cursor, what is the value of PC? 3,
It will be 4. It will be 4 actually,
4. Okay, so 4, 5,
because
6, 7.
yeah, because when we jump, when we do the call, or when we jump, which is kind of the same thing, we set ISR to 0, which means we fetch whatever is at the
Yes,
address we are jumping to,
yes,
which
yes,
should be
yes,
instruction data.
yes.
But then when we do the PC fetch, it also advances the PC so that when we finish executing the word, we can execute the next one.
Oh, wait.
The PC will always point one word ahead of where we are executing, basically.
So this is the end of word 3, like what goes before. This is the no, this is word 3.
This is word 3, which means
PC is
when we
pointing to here.
call it, yeah, when we call it, PC will be pointing to 3 and ISR will be 0. We will fetch the word so we can start running the function. But when we do that, PC will advance to 4. And then we
Uh,
start executing the first fetch, PC is at 4.
okay, so but then it's gonna be this is gonna do 5, 6, 7.
Yes, exactly.
Man, I'm so confused. I'm gonna ask you a dumb question. Does
Sure.
PC walks in the matter of words or it walks in the matter of instructions?
Words.
Words. So this is an entire word, right?
Yes.
So why is PC being incremented once we go from here to here?
Because when we do a fetch, we actually grab the data that PC is pointing to as a literal value, as a number. We push it to the data stack. But since we did a fetch, we know that this is data, so we shouldn't execute it. So we increment the
Oh,
PC
oh, oh,
and
oh,
skip
oh,
it.
oh, oh. Actually, that's my bad. So actually, PC is reading all of that in another place. This is the instructions. This is in the memory. This is a completely different thing. Okay,
Yeah,
okay. So then 5, 6, 7, right? So this is 7.
right. This should be 7.
Okay, shouldn't it be number
So
9 when it goes back though? Because this is number
number
8, right?
9. One moment. 3, 4, 5, 6, 7. Then we do a call. Should it should push an 8, I think.
Oh, you're counting 3 from here? So three,
Uh,
four, five, six, 7,
there's
maybe?
3, 4, 5, 6, 7. Oh, no, that's actually right. So it pushes this.
The
No,
7, which is
it does.
this.
It does the. It does the call to 7, which contains address 2.
Yes.
It should push an 8 to the return stack, not a 7.
Yes, that's what I'm very confused. So we are counting 4 or 3? This is the first guy.
Before we do the first fetch, we are at PC 4. PC is at 4.
Okay,
To do the
so
fetch, it goes up to
5,
5.
6, 7, 8, 9.
Yes, when we do the call, we are calling whatever is at address 7, which is the first two, but then the PC should be incremented to 8 before we push it to the return stack, and that's
No,
not
according
happening.
to what I just counted, should be 9, not 8, not 8. I'm gonna ask again.
9 would be after the jump, but then the jump doesn't
I'm
push
gonna
anything
ask
to the
again.
return.
Is this
Okay,
counting 5 or 4? Because
counting 5 or 4.
yeah, so
What do you
is
mean?
PC pointing exactly at this place with 4?
With 4, it is actually pointing to the number 3, which is after this word.
Uh, 4 is here.
So we fetch the 3 and step the PC, and then the next fetch will be address 5, which is the number 4 right below where you are.
Okay, so 5, 6, 7. Is that right?
And then when we do a yes, that's right. And then we do a call, which will call the function at address 7, which is the very first two.
Yes.
And then we should have pushed an 8 to the return stack instead of a 7.
Yeah, I have a question.
Sure.
I do have a question. So we are not doing that because we're not doing value of PC plus 1.
It should be value of PC plus 1, yes.
But then the number 1 is going to be wrong, which is right in this
Uh,
case.
that means we are forgetting to increment the PC somewhere else then.
Uh, I don't think so. I really think PC at this moment here is at word 0.
Oh no, you are actually right because we called the function that was at address 1, right? Which means that address 1 contains a number, an address, and it's not actually instruction data, so we shouldn't execute it, which means it shouldn't be in the return stack. That should be a 2 instead.
But true is this guy, no? And shouldn't, should be this.
No, 2 would be the PC when we do the halt, but then we are halting. But the point is, uh, if we reach the end of the word normally, we want to skip address 1. We don't want to execute it.
What? I'm lost. For me, we are doing an OP call. We're gonna do the call of the function, and we're gonna return. We're gonna do this.
That's not, that's in the ISR. It's not in the, that has nothing to do with the PC after we fetch it from memory.
What?
And we fetch a word at a time, which means we are fetching this block of 6 instructions first before we do anything else. That will be in the ISR,
I need to
instruction
remember
register.
that the uh, 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 conflicting with all the hardware information that I am accustomed for years. PC has nothing to do with the instructions. It has to do with the memory. ISR has to do with instructions. I need to remember that.
Yes, so we have to push value of PC plus 1 into the return stack when we do a call. We are currently not doing that. That's wrong.
I believe it's this. Yes, it is that. I have no idea if this
Uh,
makes sense, but let's go. Uh,
so we do a call. The data stack is 345,
yeah,
right?
that's so number 2 is here. That's correct. Then we do a 3 4 5, 2 8. That makes sense. We do a plus.
That makes sense. Do a plus.
The 4 and the 5 is gonna be 9. Then we're gonna return, which means that we're gonna pop the 8, which is correct. And now I don't remember what the heck we do. Uh,
And then the registered values are being reset for some reason. That's wrong.
That's wrong, but let's see what was supposed to happen. After we do the plus, we do a return, which means that we're gonna return to jump, right?
Yes, we will pop the instruction stack, which will have the jump as the next instruction. And the PC will be pointing to 9, I think.
Wait, jump is gonna use the 9? That doesn't make sense, man.
No, actually. No, it will be pointing to 8, I think. Let me count again. 0, 1, 2, 3, 4, 5, 6, 7, 8. No, it's 8. I miscounted. Off by 1. Hardest problem in computer science.
Okay, so let's try to understand why it is not doing things. So where are we actually clearing things up? Um,
Let's see. We popped the return stack. We grabbed the popped value. We put it in the PC.
and we are actually grabbing whatever we pushed into the thing, into the ISR. But both of them are just doing a bunch of nothing.
That's yeah. That's not right.
Okay, so let's try to add some prints here to help us. So the first thing that I want to see is no exceptions to see if we got there. And I actually want to see also, um I don't know if this is gonna work at all, but let's try popped value. It's so damn useless the fact that the errors show up only in the beginning. No exceptions. Number 8. No exceptions. Number 8. Right.
Okay.
That seems to be correct, I believe. Let's go back. So this is going to return to number 8.
Uh,
Number 8 is this, right?
no, number 8 is actually
This?
the address in RAM with the number 2 after the other with the number 2.
Ah, fuck, man. 0, 1, 3, 4, 5, 6, 7,
8.
8. Okay. Okay, so now we are pointing to this to 2, which basically means this.
Yes, and then we execute the jump,
Yeah, but
which
something is really wrong. Do you agree with that? Because after we discovered that there were no exceptions being tried, being thrown, uh, the values of the registers are empty.
right. Maybe we missed the maybe we do need the @ in front of the those numbers when we set the registers. They are not being used in the return
What?
instruction. Maybe we do actually need the @
Here?
in front of popped value. Yes, there and also above. Yeah. Let's try that
Oh,
out.
that
The
was
worst
wrong.
thing that
Okay, so that apparently doesn't make sense. Apparently.
oh, I think you have to. I think we have to put
Parentheses?
parentheses around it.
I don't even remember what this does. Do you remember what this does? This is not dereferencing.
Uh,
We already checked that out.
no, it's not. It's not,
And it's wrong.
and it's wrong.
Illegal type ID
Illegal
used in
type.
boxed expression.
So apparently we didn't need the @signs. So why the heck is it looking like it's empty when we do the set object?
Weird, right?
Yes, it is weird. It is very weird.
It is weird. yeah.
We need a weird layer.
Oh boy. Let's try to think a little bit. Let's try to think. May I ask, shouldn't we do this, like integer value thing, in here, as we did with value of PC? Aren't we doing
Um,
that in other places? No, we are not doing the. Oh, but it didn't test the jumping plus. We didn't test it, so maybe it's wrong. Where is
it
there
could.
any instruction that we tested that it is using this sort of crap?
I don't
This one,
think
push
so.
into R. We didn't test any of
Uh,
them?
Not yet. No, in this example, I wrote that program in such a way that I wanted to make sure that the instruction stack is working. That's what the test is focusing on.
I understand, but but I think it's very clear that this is not working.
It
I
is.
do
It is
think
clear.
that. I do
I do
think
agree.
that.
Maybe we do need to grab the integer value and then do the.
But that doesn't make a lot of sense. Like, I think nothing would work if we're not doing that anywhere then. You know what I mean? Like, and things are working just fine. Only the return is kind of destroyed. Oh boy.
It was hit by an instant kill.
Okay, so this is definitely an error. Because this is the print, this is the data stack, and the registers are completely screwed. Because we're printing afterwards. We are printing afterwards. I
We are
really don't understand
printing
this.
afterwards.
I really don't understand.
I don't understand either. It's
Okay, let's try.
confusing.
Let's try integer value. So this is gonna be in ns integer. I'm gonna only fix that one for now.
You
Oh,
have to put the x now in front of the popped value.
yes. But you see what happened there?
And now I think you need the parens in front of the in front of the thing.
Nothing at all. But before doing that, it did something. You notice that?
Where?
Look.
Yes. Oh wait.
Oh no, but this is wrong.
Returns.
No, but this is wrong. This is wrong. No, wait. This is not wrong.
Yeah, no, no.
Oh no,
It's
it is wrong. This is not the return. This is the plus. So never mind.
this is the plus.
Yeah,
Yes, this
never
is the
mind.
plus.
Never mind. Yeah, this is the returning, and this it's completely empty.
It is completely empty.
That doesn't make any sense. Like that doesn't make any sense. And there's another thing. We are not printing the. We are forgetting something. We need the instruction stack.
We need the instruction stack. Yes, we do. Actually, I think it's better to print that after the return stack because the instruction stack and the return stack, they maintain an invariance that they both have to be the same length. So having them next to each other makes more sense.
Okay. Nothing. There's nothing in the instruction stack, man.
Uh,
Oh, then that actually makes a ton of sense why the ISR is wrong.
Actually, go back to the VM init real quick.
Init. Oops.
Init, yes.
Oh, you guys are not initializing it.
Yeah, that's not gonna work. That's never gonna work.
Yeah, good catch. Instruction stack.
Now something should happen, I think.
Oh, okay. Jumping, jumping, my man, and halting, my man. Man.
Magic. We just have to initialize stuff and it works.
Who would have guessed? Cool. Uh,
But now we have a program that does function calls, it returns, it tail calls even, and it computes the number 12.
okay, we should do something else though. Let's do two things in parallel, okay? I'm gonna add
Okay,
the boring NS logs, and you will
okay.
try to gather a program that is gonna use all of these instructions.
All of them.
Yeah,
All of them.
yeah.
That, man, that's a tall order.
But I have a bunch of these to do, so you have time.
Uh,
You could, for instance, try to make like a factorial with some set of instructions, and the remaining set you do like Fibonacci or whatever.
uh, I guess. Um, the thing is,
I guess.
the thing is, I'm not used to that multiply step instruction like the from this particular architecture. Um,
Okay, so then you just don't do that right now.
right. Which means, let me look at the opcodes. And oh, by the way, did you know that Clang actually comes with an LSP for C code?
Who?
Clang, the compiler, it actually comes with
Oh,
Clang D, which is an LSP for
oh, I
C and
didn't
C++.
know that. I definitely didn't know that.
Yeah, that's actually pretty convenient.
Yeah. And I also gonna have to change all these instruction OPs to methods as well. So I'm gonna have some work to do. But we fixed the bug.
Uh,
The bug was basically adding a +1 and
and initializing the instruction stack, which we
yeah,
forgot to do.
yes. Oh, and
See,
setting
that's
the
why
ISR to 0.
setting the ISR to 0. Yeah. Uh, See, the initializing thing, that's kind of why I prefer actually one point where I prefer languages where you have to initialize the value when you bind the name. Like that's not a thing that needs to happen in C,
Or Fortran.
which or Fortran for that matter, yeah. Because like if you are forced to provide a value for that variable as soon as you declare it, this kind of error just can't happen.
Oh man, I'm gonna have to change all of them after. I'm so sad. That's fine. Part of the work is doing refactoring anyway. And Magetta is using indentation by tabs, man. I'm not a fan of that.
Yes, I didn't even notice.
Yeah, he's.
Yeah, I'm not a big fan of tabs either. Um, I would be a fan of tabs if elastic tab stops were a thing. Like the idea is there, but it hasn't been implemented anywhere, so it's not a thing. So I have no reason to use tabs, so spaces are better because it's more uniform.
I actually started to appreciate tabs after writing enough Lisps.
Oh, why?
I have no idea. All of a sudden, I was, man, I'm more into spaces than tabs now. This should be a function, by the way. Oh,
The the instruction decoding basically.
yeah.
Or not actually. That's the dispatch actually, not the decoding. The decoding is the switch afterwards.
Yeah,
Oh, not the switch, the if
that's
else chain.
yeah. This is this. Well, I don't know if I would call it dispatching, but like fetch, whatever.
Uh, no, actually, it steps the instruction that we're executing. Like it's the next instruction
Yeah, but
basically.
I'm gonna do this in proper commits. So let's try to go through the changes here. Okay, so
Right.
this is
In the
basically a typo.
meantime,
Uh,
Chime,
no,
headers,
no, I don't want
up.
to. I don't want to stage all of them. You. Okay, thank you very much, sir. Yes. I don't want to stage all of them. Oh, it's because I'm doing the wrong type. It was in caps. Uh, okay. So let's actually commit this. Change order of op halt instruction in opcode enum. Then you
Oh,
and
by
you
the way, I already know that the not instruction is wrong.
not.
Yes, that was a comment I left in the PR, and we didn't look at the comments of the PR, me and Mageda and I, when we are doing the previous
Okay,
sessions. So
let's fix that in 2 minutes. Add print state function to check VM's internals. Okay, let's fix that now. So not, right? Instruction not.
yes,
So let's go to there. So let's go to instructions, instructions, and we want not there. So what is wrong here? Probably it's because this is not.
it should be a tilde instead of exclamation mark. Uh, Fun fact: exclamation mark is not, but it's the boolean not the bitwise not.
I'm gonna also
It's
start
the
fixing the problems that for some random reason it's the indentation. Yeah, those are my comments. Yes, all of this makes sense. This so should be a method, man. This is literally a function that does void. Don't need to do side effects in the pointer. This is clearly like a method thing. Okay.
I
Is there
mean,
anything else?
all of those functions do side effects, so I don't see why they shouldn't be methods.
Yeah, that's what I said. So anything else in this
Uh,
file?
Nothing comes to mind.
Okay, so let's go to here. Fix implementation of not and outer indentation. Okay, now the big boy. Oh, I should add the print state implementation. So let's actually.
The and, not, or, XOR.
Oops. Add implementation of print state. You don't need to do fancy stuff, okay? Like, I'm not asking you
No,
to implement rule 100, I think is the name.
I'm just
But we're
trying
gonna
to
do
come up
that
with
though. We're gonna
something.
do that. Not now. We need syscalls first.
By the way, even though we have added a couple instructions, we still haven't gone over the 32 instruction limit.
Wait, what?
Like, we have not and or. I'm pretty sure or isn't in the instruction set. It only has and, not, and XOR.
Oh, because you can
And
implement OR with those, right?
yes, uh, because with and not, you have NAND basically, and
And
NAND
if you have
is
NAND, you have the game. You basically have the game.
okay. Um, and then we also added the halt instruction,
Yes.
which is not in the paper.
Yes.
Uh, but the paper had three undefined instructions codes,
That's okay.
so we have room for one more.
No, but you're gonna upgrade to 6 bits. It's fine.
That's fine. Okay, PC fetch is obviously well tested because it's used basically every
Yes,
time
yes,
we
yes,
have
yes, yes,
to
yes, yes.
advance. Jump and call are working. We need jump 0 and jump plus, which are conditional jumps. And for that,
And
I
the
think I'm
examples that
actually
you're gonna do are gonna be our golden, our what's the name? There's a name. Golden
gold
something something.
standard.
Golden model. That's the name. So these programs that you're gonna write that uses the entire instruction set to make sense. These are gonna be the golden model, which means that every single time we do a change in instruction, we're gonna run these programs, and if they're not okay, you're not merging your PR.
We could even make a CI pipeline for that, right?
Yes, we could make a CI pipeline.
Right. So I think for the conditional jumps,
Oh, wait a second, man. We should test another thing actually. We didn't
what?
test a thing. So we should. Oh my fuck. Ctrl X B. Let's go to VMM. We should actually undo what we did, and let's use ID here and see if it still
Right,
works.
right, right, right. And get rid of the at open
But
paren
maybe that
of
was
value.
what solved the problem, right? I don't
Right?
remember anymore what
Probably
solved the
not.
problem.
What solved the problem was initializing the instruction stack.
Ah, 12.
12, yeah.
Really nice. Okay, so this is basically something that we shouldn't change, which is better. Okay, go on. You were saying something?
Actually, there's even a minor improvement you can do. We are saving the popped value to a variable called popped value. We could just inline the pop into the set object argument, right? That
Wait,
could work.
repeat, please.
Like line 252, we could inline the return stack pop into line
Oh,
254
we could,
instead
we
of
could, we could, we could, we could. But we're not gonna do that. That's gonna be very ugly.
why? It would make it actually uniform. Like,
No, it's not
because line
uniform.
250,
We are doing that all the time, popping stuff
no, I mean, it
separately.
would be uniform relative to the line in between those two, actually. So,
Maybe not now. Maybe in a future change.
okay. So
Um,
I
so this
actually
is
I have
fixing
an
the bug.
idea. So actually, I have an idea for a nice function to test the conditional jumps. There's
Wait, that.
actually a program in the paper that computes triangular numbers. We could use that.
Oh, that's cool. It uses a bunch of instructions.
It uses, well, it uses the conditional jumps, obviously, which is one thing. I'm pretty sure it uses some stack manipulation as well. Let me double check. Oh, where is it?
Okay, and then so this is fixing
Triangular.
indentation.
Yeah, actually, there is a. I can just basically copy this program from the paper and it should work, I think.
Okay, so here's the kick. So should I? I think I'm gonna do that now, man. You're gonna have a long ride to write the programs, right?
Probably.
Yeah. So what I'm gonna do, I'm gonna change these things to be methods then. Okay. So let's do that. So instructions. So all of these will migrate. They will migrate to VM. Look at that, man. Yeah, but my Control D is fucked for some reason. I don't understand. So D. No, that's not what I want.
Over jump 0. And you know what annoys me so much in the algorithm 19 of the paper, which is the triangular tail recursive, the triangular number tail recursive implementation. It bothers me because it's not actually tail recursive, like
Oh.
properly. There's a call followed by a return. It should just be a jump. That would be strictly better.
Hello, good night, everyone.
Good
Hello,
night.
Magetta.
We are live. Maget, do you remember the name
Good
of the
evening,
shortcut
at this time.
that was originally Control D, and for some random reason my Emacs it changed that. I don't know why.
You mean, first of all, actually, good evening. I say good
Yeah. Good
night.
evening.
Control D, you mean the MC next character?
No, not next character. When you
Word,
select a piece of
word.
text and
MC, type MC,
MC.
MC slash. I mean, like searching for the commands, right?
Oh. No, but don't you remember? Don't you know the name? The one that you select a
Yes, but
block of text and then you keep
yes,
doing the
I know.
shortcut.
I know it's AMC. It's a multi-cursor.
Oh, so
So type MC
multi-cursor.
slash. No, no, it's MC slash. It's something like this. MC. No,
Am
meta
you
X.
saying meta?
Meta X.
Yes.
MC. Literally type MC. Yes. Slash, and those are all the functions for that thing. And then it's
Yeah, but I don't have Control
Yeah.
D. Oh
there, there,
wait,
there,
there's
there.
more.
It's up there. I just saw it. It's control and then yeah, right or left. You see? Angle brackets.
When and who changed that?
I don't know, but that's my Max configuration.
Okay, I definitely was not using this one, but that's okay.
Yeah, I was using at some point Control D, but then I decided to change.
And
Again.
yes. No, I don't want that actually. So how do I make parentheses? Oh, thank you. Void.
And I wonder how
Okay.
much work it would be to make Emacs behave like a cone.
Like oh, another idea. I
Yeah.
presume.
It's modal, yes, but also it uses multiple selections for basically everything, and it's very nice. And since Emacs has multi-cursors, it should be able to emulate Kakone's behavior.
It's not Emacs per se. It's a library that provides that for Emacs. Right.
Oh, it's a library, I see.
Yeah, there are multiple libraries that does that.
So I will not ask why you are removing everything from there because
Yeah.
I assume that you're already adding that as methods for the VM.
Yeah.
So you already have access, and I need to have dinner, so I'll be
Okay, so
right
let
back.
me tell you what we did. Are you there?
Yes, what
So
have
we
you
fixed
done?
the bug,
Right.
and Mageta, not Mageta, Marinho explained to me what you guys did. And now Marinho is making a program that will try to exhaust all the available instructions. And I
Right.
am fixing the indentation and adding logging to the new
Hmm.
instructions and transforming the instructions from functions to methods.
Okay. So next steps, I assume we can start with the syscalls, maybe.
If the instruction set that Marinho is doing is correct, because we're gonna try it, right? If that's correct, we're gonna do that.
One thing that we could also rewrite as soon as we have this working, um, are like the arithmetic functions. I
Are they wrong?
No, I
No,
don't think
it's
they're
just
wrong.
that,
It's just that we don't have like division. We just have you see like subtraction and uh
yeah, it's too low level, is what Mageta is saying.
yeah,
Okay. Have good dinner, Magete.
yeah. I'll be right back if you guys are
Have
still
a,
here.
We're gonna be
have a
here.
nice meal. We're gonna be here, probably.
Yeah.
As long as nothing catches fire or blows up or whatever, we should still be here.
Yeah, 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 yeah. Wait, do we need to put void in these things? Do you think so? I don't think we need, because that's not the convention that we are following. These things are all doing receiving void, and we are not doing. So I'm not gonna do. Oops.
Ah, am I the only person who thinks camel keys is weird after looking at kebab keys in Lisps for so long?
Probably.
Like,
Well, I'm not like
I
I prefer camel case, but I'm not saying like, oh, I'm gonna hate you if you like snake case.
yeah, I think if we can't use kebab keys because your language is dumb and you can't do hyphenation inside of symbols, you should go with snake keys because it's more readable for long names.
I agree, but you should. A lot of time you shouldn't have long names.
I'm a bit ambivalent on whether or not you should have long names because Lisp tradition is to have long names, long descriptive names, but Forth tradition is to have short and easily easily visually identifiable, not identifiable necessarily, but Forth tradition is to have short names and Lisp tradition is to have long names, and I'm kind of in between, so I don't know what I prefer.
uh, so let's go to instructions. It's very sad that we can't have some implementations of the class in one file and some other ones in another file. That would be
Like
very
split the
poggers.
class into two files.
Yeah, because then we could have like the core functionality of the VM
Ah,
in one
I mean,
place and the
technically
instructions
you
on the VM.
technically you could make a separate file, write it with the secondary things, and then just include it in the main file, the official file.
Are we gonna do that?
I don't know. That seems kind of messy.
But it's gonna get messy anyway. We already have 300 lines. Like, what are you talking about? I think we should try to split, man. But I don't know if that's possible. Let's try. So let's say, for instance, who is here? Nathan. Hello, Nathan.
Hello.
Let's try. Let's just see what happens. I really want to know what happens. So I'm gonna comment all of this. I suppose you need to put some sort of yes, some sort of that. And let's
By the
try.
way,
Go.
I'm exploiting the fact that I recently configured my editor to show line numbers, and I'm using them as the instruction addresses for the code I'm writing.
I told you it's gonna be useful for you as well. I told you. Told you.
Warned
Um,
me about the stairs.
okay, I don't think we need any of this, so it's gonna be that.
Over jump zero
And we don't
over
need this as well.
plus push R. Is it push R? Push R. Another thing I did recently to improve my configuration, I actually set up my editor to use ripgrep as the grep command instead of the
No,
default
that's
grep.
that's very cool. That's very cool. I should do this in Emacs as well. So how to import multiple implementations of class Objective C? How specific is this question?
So, like, there are basically two answers to that question. You could make a superclass and inherit from that, or you could do what I suggested, which is the C way, which is you make a separate file and instead of importing it, you include it.
Oh, so you're no, but are both do both files contain this
I don't think so. No, in my case, in my idea, it
suggestion? So you
wouldn't.
basically have them like loose like this,
Yeah, because
and then in the implementation thing, you just basically do an include.
what include does it literally just splices the text of one file into another.
So you're basically saying to do instructions.m. That's what you're saying.
Yeah, and that should be after the implementation VM, I think.
Okay, so you're basically saying this, but down here, after the end or before the end.
Shouldn't matter. Actually, it's probably better to put it before because
I
then
don't
we
think
don't
that's gonna
have to
make a bunch
worry.
of sense, man, because we need some of these functions in this block here. So I think it's gonna should be here.
Yeah, yeah. At the beginning is better because then you don't have to worry about order of declarations, like all the things that you depend on are at the beginning.
Okay, so let me. Oh man, that mean to test this, we're gonna have to have all of them converted. Ah, fuck. Okay. So void.
Uh, so what does okay? So we have right. So we get an argument, and there's an accumulator, which means that actually the function that would be called in the top level
Oh, let
should
me explain to Nathan what the heck you're talking about. So, Nathan, we are basically right now fixing a PR, and I asked Marinho to make a program or two programs or something like that to exhaust all the instructions that we already implemented, which I believe are all of them, aside from syscalls. So that's what
um,
he's talking about. I'm very sleepy. Very hard to me to grasp anything. Okay, so we are making a virtual machine, right? A virtual machine has like basic instructions, and we implemented them. And but of course, in the because we are following Mageta's way, we don't have tests, which means that we don't know if they work. We don't know if the instructions work. So that's what we're doing. That's what I asked Marin to do. No, but
yeah,
two examples, like two examples only. That will a program that will use all, or two programs that will use all of them.
fetch, jump, over, jump 0, plus push and pop R, those are important. Another jump, drop, return. And this is so short, it's gonna test so few instructions. Like the big advantage of concatenative code where you can compose a lot of things out of simpler things is gonna kill us in these tests because it's so easy to do stuff that you don't even use half of the instruction set most of the time.
Yeah, but we are implementing it, so we need full instruction set testing. We need that.
Okay, so we set a 0 for the accumulator, then we jump to 4, which is the actual loop, kind of, and we grab the value we got as an argument, while simultaneously putting it, I really don't like over, but it's what we have. If it's 0, we skip to the end, and this should be a 9 now. And the end just hides the accumulator, drops the inputs, which we know to be 0. Correct.
Yeah, we are
Well, it
doing
is
that right now. We already have an example that does that, and not with shifts, but with jumps. And it did work. Oh, in x86 64, I don't think so.
jump
Usually in
to the
university we only tackle like RISC-V or MIPS.
This is Lemos's first contact with a stack architecture,
No, this is
like
not
a
my
very
first
low.
because Zozing, but this is one of my first. This is my first time implementing it for sure.
Is this different from what Zoldin did
Yes,
or
it
not?
is. It is. It is
Oh,
very
I see.
different than what I did.
Did he have the whole multiple stacks thing?
He only had two stacks.
Right, so no instruction stack, which means one instruction per word. That seems very wasteful.
From a hardware perspective, yes. From a software perspective, nah. Memory is cheap. Go buy memory.
No, man, cache locality is a thing. Nathan, answering your question, what's that multiple stack thing? Basically, there's a data stack, which is where arguments and return values live. There's the return stack, which contains the return addresses for the function calls. So, like, whenever you call a function, you push the program counter into the return stack, and when you return, you pop the return stack into the program counter. There's also an instruction stack that is synchronized with the return stack because in the architecture we're implementing it, we have multiple instructions per word. And if we do a call, we don't want to discard the instructions we haven't executed yet. So there's also an instruction stack. So the words we are currently executing gets pushed into that when we call. Um, so our machine has three stacks basically. Um,
Yeah, it didn't work, Marinho. The idea
you didn't.
didn't
How
work.
sad.
Didn't
How
work. So it's
sad.
complaining about RAM. So like,
Oh, did you put the methods like
hmm?
the include for the methods? Did you put it after you declared the fields? Because we kind of depend on the fields, right?
That doesn't make sense. The fields are already being declared in the vm.h.
Oh, right. What are the trade-offs?
Oh wait. We need that then. We need those. Seems wrong. Yeah, are we still implicit
But
declaration of function?
the
Oh, this makes sense.
trade-offs,
This makes sense actually.
the trade-offs for software implementation, they are basically non-existent. This is pure win. For a hardware implementation, though, you have very fast stacks because they can be implemented in the processor instead of being in the main memory. But then they will be limited in size because they are in the processor and not in the main memory. So you have to be aware of how deep you are in each of the stacks.
Okay, so I don't think it worked at all, Marinho. I really don't think it worked at all.
Isn't
So,
that expensive? Not really. Like for typical fourth chips, like the ones that Chuck Moore makes, they usually have like 16 deep stacks. I don't think they have. I don't know if instruction stacks are common for them, but I don't see why they wouldn't be. But like that's like having, I don't know, 16 times 3. That's what, 48 registers, and they are not general purpose registers. Most of them. So and because the communication between them is very simple, you also save on having to implement that logic that routes things between the registers elsewhere in the processor as well. No, you do not have a stack on RAM. You could, like, there are some architectures where if you overflow the stack, you can spill into RAM. That's not the case for the one we're implementing, but you could have that.
I'm really not sure if we can have the different implementations of the class in different files. I really don't think so, which is really sad. Really sad.
Um, I guess there's one trade-off to encoding the code this way with the instruction stack thing. I mean, is it a trade-off? I don't
And I'm
know.
back.
Basically, we are packing several instructions in each word, which means that
I'm gonna have to interrupt you, Marinho. Could you answer in the chat?
answer. Sure, I can.
Magetta, question for you.
Yes, sir.
Can we have the same implementation of a class in multiple files? Does it need to be in a single file?
It doesn't matter as long as it defines the methods and it imports. It shouldn't matter.
So look at this. Look at my screen. I converted all of them to methods.
Hmm.
Oops. And oops again. And I want to import that in this file here, which is the vm.m.
I see.
Because
Oh, I see what you
I don't
mean.
I want these methods to be in this thing, but I want it to be just in a separate file just for organization purposes.
Yeah, I see. So, oh man. Okay,
Is
so
this
maybe
possible? That's the question.
maybe that is not possible because it will not be part of the implementation because you define implementation by that on line 13. You see?
Yeah, yeah, I
Uh,
see
the
that.
second buffer.
I totally
So,
see that.
but the thing is, I think you might be able to put the VM, the implementation, on both places. You might. I'm not sure. Maybe you can. Let me see.
Yeah, what I really the problem is that this file by itself, it doesn't know how to handle the fields because it doesn't know it's part of which class it's part of. But if I add the things saying that it is an implementation of a VM,
Mm-hmm.
then it throws another different error. Uh, and I don't know how to search that in Google, man. How to combine implementations? I have no idea.
Oh, by the way, have you ever seen the Eduardo, the hedgehog?
No.
No,
I'll send here. That's Eduardo, the hedgehog.
I don't know. I don't know what you're talking about. Let me see. What the heck is that, man?
I just found it today, Victor. Oh, that is very interesting. So you can do it. So
Teach me.
search for Objective C categories. No, I'm not joking.
Yeah, but what a name.
So you
Category.
apparently import it using import, and then you put the name of the class, which is the .h, plus the other file that you implemented with the .h
Can you
as
send me
well.
the link because the Apple site that I found is not helping me at all.
No,
Oh no,
I
Geeks
wouldn't.
for Geeks found it. So you do an interface thingy, is that right?
Yes, sir. Apparently, yes. So you do the method declaration. Yeah, but this is still not really doing what we want. Because you see that it's doing the method declarations and then it does the definitions somewhere else.
Yeah. No, but this is we are already doing that as
Yeah,
well.
we already do. But I think the thing that is useful out of that is the plus. You see?
It's the
Look at the
plus.
import. Look at the plus on the import.
I don't know if we are looking into the same thing.
The second block of the link I sent.
Oh, you sent something there. Okay, so the plus, the second block, my class plus networking.h.
Yeah, look at this example here.
All you have to do is create a new .h.m pair, and in the h you do that. What if I want
That's
to
example.
declare? Let's try
So
that. I'm very curious to see if that works. Let's try. So let's go to instructions.h now. So instructions.h. Uh, we're gonna import my class. So that's basically gonna be vm.h. All
if
right.
your core data class is named person, your implementation could go in the category implementation. But note that you have to declare all of your IVARs in the main interface of your class.
What
Let's
is
see
networking
category.
there, by the way?
Well, it's one class. So you have basically look at the second example. I sent the code on Discord.
Look at this second. I'm gonna copy. I'm
So
gonna paste this on the screen that I'm
on the
sharing
screen.
here. Here.
Yeah, okay. So what the guy's saying, apparently that's a feature called categories and extensions. So you can define uh, the implementation as the intermediary class that will share part of the implementation between all of the other things you have. So you define, in that case, he's defining the interface, the abstract class, right, on the line 8 to 10.
Mm-hmm.
And that's supposed to be one file. And then he imports that plus an external implementation.
That's weird.
And yes, that's very weird. And then he's passing that as parameters, like
Okay, but
for the
what's
development.
implementation here? What this is doing?
So this is the feature called category.
So this is a category.
I'll read what the Apple documentation says. You use categories to define additional methods of an existing class, even one whose source code is unavailable to you, without subclassing. You typically use a category to add methods to an existing class, such as one defined in the Cocoa frameworks. The added methods are inherited by subclasses and are indistinguishable at runtime from the original methods of the class. You can also use categories on your own classes to distribute the implementation of your own classes in different separate source files, which is
Which is
exactly what we
exactly what
do.
we want.
So, for example,
Yeah.
you could group the methods of a large class into several categories and put each category in a different file,
I have a
or
question.
declare private methods. Oh, that's
I
interesting.
have a question.
Okay.
So can I define, as far as I understood from what you read, we can do this to extend existing classes, right? But
Yes.
what if the methods that I want are already in the class, right?
Well,
Or should they not just not be here?
yeah, just don't. Yes.
Okay. Then in the H file, we're gonna
I mean,
import the
you
VM.
can. Here's the thing. Keep them there because here's the point. Like, I'll send another example, but you can also use this for. I'll send the Apple Docs. Okay, I think that's easier. But you can also use this for private methods. So if you see
Yes. That
on
makes a
the
ton of sense. That makes a ton of
you see
sense.
so on the example, the guy's doing private methods on the interface, but on the implementation, he's not passing anything because that's private. No. So if you define them there and you leave them, then you're going to require the implementation to support them, but you're going to provide that by the instructions on the VM.
Yeah.
So we can use that.
Well, but
Man,
in this
that's
particular
very weird, but very interesting.
But is the in this particular case, I want to try without them, like to try to mimic that this is actually an
Yeah, just
extension.
comment. Just comment, don't delete for now.
And I got some news in the meantime. So apparently I passed my computation theory course.
No, that's good.
I was very worried, man. The exam yesterday was very stressful. Okay. So how do I define a category? Is just this?
So I think that's just an import file. Like you do the
No, wait. I'm confused. We are on instructions.h, which is the extension, quote unquote.
oh wait. The declaration of a category interface
Yeah,
looks
I
very
want.
much like an interface declaration. So it is the same thing. Interface system class and then you pass the category name.
Okay. So I'm defining an interface for VM, which is a class. I'm calling that instructions, and I'm providing the declarations of all of them. Then, in the .m file, which we also have,
Oh, wait, what?
instructions.
Oh, that is very weird. So you define it as a class, and then you
Yes.
just put the name of that class, like like instructions, right?
Yes. Like this.
Wait, line 14 are the instructions, right?
Yeah.
You
So
mentioned that.
we're gonna change that.
So it's not, yeah, okay.
So I also think this should be this.
Yes.
Then we're gonna do implementation VM instructions.
It's not, wait. That's not VM. That is the instructions.
No, but this is person in the example.
No, man, like, here's the thing. The thing that you need to define first the category, the base, the interface, which is the class, and then the instance of the definition of the class.
But we have all of
So,
those. Here on the right, we have the definition of the interface VM, right? Am I
yeah,
saying
so
things
that
right?
is the interface for the class, yes.
Yes.
The left, line 11, should be the instructions.
Implementation of instructions,
Yes.
like this.
Yes.
I have no idea what this means then.
So this is basically the definition of the second class. By the way, the interface, you need to now pass the instructions as a parameter to the interface. Line 7 on the
Here,
other file. No, after the VM, right? Before the
after.
NS object.
Okay. So here
Yeah.
we declare that we have a category.
Yes, sir.
How do
And
we
I
do
don't think,
multiple ones?
and
Can
I
we
don't think
do
you need the
blah?
NS object, by the way. I don't know, but I suppose.
That's true.
Just remove the NS object. And then what you need to
I actually
do,
prefer the NS object to remember me that this is just inheriting from this.
I don't know if you can. That's the point.
Oh,
Well, leave it there. I
let's
don't
try.
know.
Let's try.
I don't see it any example. So, and then I'll go on the implementation of the.
Of the VM.
Uh, yes.
Okay.
Oh wait. Oh right. Just like the other thing, you need to do the interface and the implementation of the instructions. So you need to also do at interface instructions and blah blah blah. You see?
Add interface instructions. So you're saying to do interface
Instructions.
instructions, and this is gonna be the
And as well,
declarations.
it's like what you commented from line 23 down on
Oh,
the
okay, so this
second
is
line
not.
buffer.
This is we are in the wrong file. So what you're talking about should be in this file, right?
Wait, no.
No.
Oh man, wait. We are very confused.
Yes.
So here's what you need to do. You need to have a file that contains first the 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 instructions. So you need to define both the interface for the instructions and the implementation for the instructions, right?
Yes.
So far so good. We don't have that. What you have there is the implementation, is the interface for the VM. That is not the case. You need to do instructions there because those are the new instructions that are gonna aggregate to the VM,
Yeah.
right?
Okay.
So that's it. Now
We
I'll
don't
go
need this
back
import
to.
here then.
No, you don't.
Okay, so actually we do. We probably need this thing here.
Yeah. I mean, you don't, but yeah.
So ins.
Don't forget the end as well.
Yes, I'm not gonna forget. I really want to see if this is gonna work because I'm confused.
You might need the framework foundation, by the way.
Okay. So instruction, and we also gonna need the import that we have here.
It's not all caps, by the way. It's just all caps on the VM because, well, it's VM.
When I was in university, it was all caps all the time.
Well, it's certainly not what Xcode was doing, but well, anyway,
No, but I can change that. Not a
I
problem.
couldn't care less. No, I mean like instruction with the I capital, and the rest is normal. But well, I mean whatever.
No,
It
that's fine.
probably follows the file name, right?
Yes, that's what I say.
There. Okay, so let me try to recap. So we are defining an interface called instructions, and we're gonna use that later. But I have another question. These things are using VM things, right? Do you
Yeah,
understand that? Okay. So that is still fine.
I hope.
Okay. And then in the .m file, what the? Oh, I didn't save. Okay. In the .m file, what we're gonna do?
So actually, I don't know because you're using data stack and all the rest there, right?
Yeah, I'm using VM's things. That's why I was very confused when you said we're gonna need to define an interface called instructions, and they're gonna
No,
have
that's a
these things.
category, not an interface.
Wait, this is a category?
Yes, instructions is a category.
But is this the way
Yes,
to declare it?
it has the name interface, but it's a category.
So do I need to import this file? I think.
So what? No, man, not there. You're okay. There you do as well because you need to reference. Yes.
Yes. Go.
So, headers, I think.
No,
Oh
but
no,
this is
you are
already in
already inside
headers.
header. Yeah, never mind. So go on the implementation for the VM. I'm not sure
VM.
if that's gonna work, but let's see.
I was so excited and now I'm not hopeful.
On the implementation, add the category.
Yeah, but this
And
is.
by the way, you don't need to import the M, just
Yeah,
the
no, this
H.
was a previous attempt. This was a previous attempt. Okay. This is not
Okay,
gonna
that
work because there isn't an implementation of any of those here.
what do you mean?
There isn't. There isn't. This file
Wait,
doesn't have
I,
any
I don't,
implementation of the
I
interface
don't follow. Implementation of what?
of the
Which
ones that we
interface?
declared when defining the category instructions.
Well, you are defining the interface instructions, and you have those implemented, don't you?
Not here.
In the instructions.m, don't you?
Yes. Yes, I do.
So that should be it. The linker should do that job.
Oh, so it's gonna discover that the
Yeah,
implementations.
that's the whole point, right? It's separating
I
the methods
really
of
didn't
different
understand in
files.
that way, man. Really. Like, how it's gonna discover that the things are these ones?
Oh, yeah, remove that.
And look at, is this right?
Oh, no, yes. So you need to do that on the instantiation of the second.
Oh, the VM then.
So yeah, I think that's how it knows. You need to put the VM import plus the instructions. So you don't actually do it there.
Like
Oh no,
this?
I think you do in both places. Wait. Yes, I think so.
It's weird as fuck. Okay.
Yeah, but
Uh,
if you are already on the instructions, you need a header. Yes. So I think that's it.
okay,
I don't
so.
think you need the .h, by the way. It's just one .h on the end.
Oh, this?
Yes.
Do I need headers though?
Well, yes, I think so.
Okay. Okay. So let's see if I understand. Given this import, it's gonna discover that, oh, this thing is a combination of two things, and
Yes.
one of the and one of them is here. Part of it is here, and the other part is in another place, which is this.
Yes, that's what the doc said, at least.
I really don't think that's gonna work. Okay. Cannot find interface declaration for VM.
Interface declaration for VM. In which file?
In the vm.h.
Okay, so can you go there?
Yes.
Oh, I think I know.
Uh, there we go.
So you are adding instructions, but you wait. That's the what? I'm confused. Bro, wait. What the heck?
Don't we have an example of using this in Apple's thing?
No, wait. I don't get the error message. Go back there.
The error message is saying that there isn't a declaration, apparently.
Cannot find interface declaration for VM, and then it is. Oh, it's the NS object.
Oh, you think it's the NS object? Let's remove it.
Try omitting it.
Okay.
So one
Now,
error disappeared, but
cannot find interface declaration. So that's the thing. I think that the interface declaration and the category, they are two different things, man. Which means that we need a
man,
file
the
for the.
documentation says it is the same. Look, the declaration of a category interface looks very much like a class declaration interface declaration, except that the category name is listed within parentheses after the class name,
Can I ask? Can
and
I
the
ask a thing?
superclass isn't mentioned.
Can I ask something?
Yeah, go.
So do you see that in the example that you just read, the code below, we have import system class. I bet you that that's where the class is being declared.
So let me read this passage again. Except that the category name is listed within parentheses after the class name in the superclass isn't mentioned, so the NS object disappears. A category must import the interface file of the class it extends.
Yeah, so we need so what we are seeing here is a category in the declaration, and we need the class declaration somewhere else. And I believe the somewhere else is system class.h. And that's why it's not working. That's why it's not finding VM, because this is
Man,
the
that
declaration
doesn't
of an
make sense.
of a category.
That doesn't make sense to me because if this is to extend something that already exists, you are not going to define something that already exists. You're just gonna add it right to the class.
Yeah, but that's the thing. I think the system class.h is defining it in the first place, okay? And then the interface system class category name is basically doing the extension. But these are two separate declarations. This, what we're trying to do here, this error message makes sense because we didn't declare the VM
So
first.
man, so wait, it's the other way around if that's the case, because it would be going back to the example. It's importing the system class H.
Yes.
So it would be you define again the same thing, and then you just add the category name, which should be instructions, which should be not instructions, sorry, which should be the VM. Like it's weird.
Yeah, I
So the
understand that
class,
there may be some redundancy there.
no,
I
no, it's not a
understand.
redundancy. It's like it's that it's a so in our example, from if I'm right, it would be instead of system class.h, we import instructions.h, and then on the interface it is instructions, and then the category becomes VM.
I
I'll
have
read
no
it.
idea if that's the case. I
I'll read
understood
it
completely
again.
opposite. I completely.
I'll read it again.
Sure.
The declaration of a category interface looks very much like a class interface declaration, except that the category name is listed within parentheses. After, okay, I'll stop here. Okay, what is a category then? Use categories to define additional methods. I hate this kind of stuff because it's not defining what a category is, right? So just saying, yeah, you use it for that. But let's go with that. You can use categories to define additional methods for an existing class. So it's something to extend, right?
Mhm.
Going back. So you put the name of the category with parentheses, right? And then it says, after the class name and the superclass is mentioned. So if we want to extend VM, then the interface should be VM and the category should be instructions, which is what we did, but that's not the case.
Yep.
So, and then it completes. A category must import the interface file for the class it extends. So on the instructions, we will need to import the VM and the instructions as well. Define the stuff, and then on the other file, which is the definition of the VM, we need to import the interface for the instructions.
I don't know if I follow all of that. I really don't know. So let me try to explain how I got it, okay? And I'm not saying I'm right. It's just
Oh,
what made sense to me.
they have implementation down here. We are not looking.
Oh. So where is this piece of code in? That's what I want to know actually.
Man, open the code, the link I
Wait,
sent.
you do a file with a plus in the name.
Oh, you're kidding me. Wait, wait, no, no, no.
What?
No, no,
What?
But
that's not a file. That's like,
It's
man, it's
saying
right
there.
here.
If you use a category to extend a class to which you don't have the source code, or to
Oh man,
distribute
no,
the
that's so so okay. It's not a special syntax. It's just a plus. Like literally, it could be still, but it's
uh,
literally a plus. Oh
as
man.
someone who is used to working with Lisps, I don't see the problem with having a plus in the middle of a name. That's normal to me.
Yeah, you are with a disease, man. You gotta check your doctor. Uh, yes.
Oh, man. Okay, this kind of makes more sense, but it's still crazy.
Yeah, it's very crazy. Okay, that makes sense. That makes
So
sense.
you are importing a file that's in the headers directory, and inside of the headers directory, you expect there to be a vm.h plus headers directory, and inside of that directory, there's an instructions.h. Is that correct?
Yeah.
A common naming convention is that the base file of the category is the name of the class the category extends, followed by plus, followed by the name of the category. This category might be declared in a file named system class plus category name. So it's basically this. It's basically this. I'm not gonna do the if defs right now because, well, that's kind of weird. Okay, this file that just mentioned there, that is the import sysclass.h, then interface, system class, then the category name. That's okay.
So wait, man. Let's go by steps. So the VM is just the interface that should not have these instructions you have there.
Yeah, that's what I understand.
So that should be, let me see here. Okay, so from what the guy's doing is the actual name of the thing. So like it's just the name of the class, so it's actually VM and then instructions. So
Yeah.
okay, our VM dot, what's the name of the file? Let me just increase. So the buffer on the left, that is vm.instructions.h.
Yes.
That seems correct.
Yes.
So okay, and you import the VM, right?
Yes.
All right. So now go to the definition of this. Okay. So just fix the name of the import. That's wrong.
Oh yeah, that's wrong. That's
Yeah,
totally wrong.
remove the headers. This is very funny.
No, if this works, I'm gonna be so happy, man. This is one of the
And
first
so
really specific Objective C things we're gonna use.
Okay, so once we have that, then you do. If you use the category to declare private implementation, so okay, that should be it, and then you should just import that thing on the other file
Which file?
on the VM, I
This
think.
one?
Actually, no, it doesn't mention that, so I don't think we need to do anything else.
Yeah,
Yes.
that's what I'm really concerned about. It's not mentioning anything about that. It's not mentioning anything.
So I basically just invented a syntax for assembling Chime programs because traditional assembly syntax doesn't work very well when you have packed instructions. So
Oh, there's a better oh, sorry to interrupt you, Marinho, but there's a better example down there with actual code, Mageta.
On the Apple website.
Yeah, if you go down there, in the
Yes, I'm looking.
there's like that definitive discussion. Categories add methods to existing classes.
Yes, I'm checking that.
Okay, so Marinho, go continue, please.
So yeah, the file extension is chf. Ch is for Chime and F is for forth because the syntax is inspired by retroforth actually. And you pronounce it as chaff because you have to separate the wheat from the chaff.
You need to reference the plus lemmas on that.
I already did reference. I already changed the line to reference the plus. The error now is something else. Let's check.
No, wait. I'm talking about on the file, on the vm.h, you put plus.
Plus where?
No, man. The vm.m on the line 8, which is the vm.h, you
Yes.
reference the vm plus instructions,
Oh, I need to
which
define
already
those as
references
well.
the. No, wait. The VM plus instructions already references the VM.
Oh,
So you just put the other, and that's it.
I don't think that's the error, but that's a good catch. Oh, of
What?
course. Yes. Okay, so the error is the same. Okay, use of undeclared identifier data stack. So it didn't work at all because in the vm.m, it's not
Man,
recognizing.
I don't understand why the vm.m, like the m file, has everything defined.
Oh, this is wrong. Can you say again?
All right, that was wrong there. Oh, we compiled actually.
No. It is still very wrong. Yeah, this is entire. Yeah, this is implicit declaration because I didn't change them yet.
I mean, can you remove that thing?
The warning?
The yeah
I
the
didn't manage to fix these warnings. We are already using this flag, but maybe it is in the wrong position because it is in the beginning,
hmm.
and I didn't manage to fix that. But I want
Oh,
to check
remove
the
the
errors out.
wall.
So the errors are saying something along
Yeah,
the
it's
lines
mostly
of
like missing implementation.
use of undeclared identifier on VMs VM plus instructions.m. So it doesn't know what is a data stack. It doesn't know that, and that is happening on instructions VM plus instructions.m. So I don't think we did it. I don't think we did it.
Go to the VM plus instructions.h.
Sure.
You went the VM.h, so why the heck?
I don't know if the order matters.
I don't think you should.
I also don't think it should matter. Well, let's
Can
try
you go
again
to the...
just for it to see.
Mm.
Uh, no, use of undeclared identifier. So let's check the more enhanced example.
We're not doing anything different.
Yeah, but this is cool. I really like this. I want to explore this feature. Let me put on the screen. Let me actually go check if what's going on the other side. Nothing. Okay.
It's kind of a cringe one because in, you know, any other language that is like object oriented, this is very easy.
Um,
No, I don't know about any, but F sharp certainly
in
easy.
this example, the XYZ additions category declares one additional method to return the necessary string. Okay, that's exactly kinda what we want, right? Um, we want the kind of that. So he has. I really wanted to have like in the top here the name of the file. Really wanted that. But anyway, so this is the XYZ person class from the previous chapters. Oh, so
Man,
you're supposed to have read that.
man, can you open the link on the browser and just share?
Wait, you're only
I'll,
looking at my Emacs?
oh yes. Oh
What?
no, sorry, I wasn't looking at your screen. So
Oh.
okay, look at that. Can you go to the... Let me see. After the second header, the categories and add methods to an existing class. Go to the one, two, three. Go to the third block. Let's go there
Yeah,
first.
okay. So import
So,
XYZ person.
so look at that. Import a header, right?
Yes.
And then which is for another thing that you want to extend, and
Yes.
then it adds the category. So the name
Yes.
of the class, and then the name of the category with the new method, right? And then look at the next block. It is doing import of the other file you just defined. So import XYZ person with XYZ person name display additions.h, which is that previous file you did, right?
Yeah.
And then it's just implementing the same way we're doing.
Yeah.
And then on the next file is even weirder because it's basically just calling the .h and implementing the actual some object, right? So some other object that owns that all the trash that it instantiates the XYZ person, and then he has access to the extension. So the only different part is that it's actually just defining the class there. But we're doing the same, and oh, what
What?
the
What?
heck?
What?
I
What?
know.
What? Did you figure out
Go to
something?
go to the main.
Go to main. Ah.
There.
You think we need to add like plus
Yeah.
instructions?
Yes, sir.
Do you really think so? I really don't think that's a problem.
Well, that is certainly a problem because you're basically defining part of the class without the other data,
Ah,
the
okay, okay,
extensions.
that's definitely a thing. But why is not grabbing the things from the class? Are we
So
declaring a class correctly?
I don't know. I think so. Can you search in all the code for VM everywhere?
VM what?
VM.h.
Sure. There.
So that seems to be right.
And I'm so fucking happy that I passed through the course. Like you can't, you don't understand how happy I
I think that's me if I stop doing event sourcing.
am.
Man, I'm not joking. I would be very happy if I was coding, I don't know, JavaScript right now. I would do that like
So the
happily.
video the video that I sent earlier made you laugh then.
Man, that video makes me depressive actually. At first, I remember when I first saw that and I was laughing. And then like when I started working, I saw that that was not a joke. That was actually true. Like and actually
Pops to Leandro, man. Pops to
like the
Leandro.
the guy like explaining for example how to get a surname on microservices. That's literally what I do. I'm not exaggerating any bit. Just give me a sec.
Ah,
Yeah,
so
the
good.
two of us also know how that feels. Not going
No,
into
but I think
details,
he
but
does he
yeah.
does for a a long amount of time, and he also does more in a heavier intensity. Marinho.
Yeah, I don't doubt that at all. It's
So that's how he declares a class. We are doing exactly the same thing. I'm so fucking lost. Why is this cool feature not working?
I don't know.
This feature should work awesome, and it isn't working awesome. We are doing that. Interface, VM, category name, instructions. We are declaring all the extra stuff that you're gonna have. That's cool. Then, um, yeah, this is that. Then, when you're doing the implementation, how is my line of code?
Okay, I'm back.
Welcome back.
Anything or
Does the order matter? I'm gonna assume the order does matter.
I don't think you should, but well, let's see. Maybe it does. Oh, did you put the header first? The header is what matters, right?
Yeah, the headers are first.
I mean, the you put the m, but did you put the vm.h before?
Undeclared identifier. Wait, what was your
Didn't
question?
right? So can I see? Let me see.
And why the fuck you change this to headers, man, instead of include?
Um, I think it was VS Code.
How sad.
Uh, or it was my
Actually,
decision.
we
I
do have
don't
a
recall.
plan B. We have Xcode. So we
Do
can
we?
actually check if this actually makes any sense. Because maybe the problem is just the Linux gigantic command line.
Maybe could be, but I really doubt.
Because you see what's the problem? The problem is that we in the file
I
of
don't
the
know why, man.
implementation.
It doesn't make any sense to me that the vm.h, which is what failing. Oh no, it is not. Wait, it is the vm dot plus instructions.
Yeah, it's not finding the attributes from the thing, from the class. You see?
Yeah, that is weird. Can you also put on the
On the
okay? Can you also do this? Go to yes there, add the VM there too. I don't think that should be the case, but well, let's test.
I saw
Uh,
yours. Same thing. Use
that's very
of
weird.
undeclared identifier data stack. And the data stack is definitely here. I want to check his class to see what the heck is a
Could it say
person.
because the members are private?
Oh, that may be the problem. How do we make
And
them not
since they're,
private?
I don't know if they are private by default. I don't think they are. Oh,
Here's how
sir.
he's doing it.
Oh, that is the standard way. But I think maybe the standard way is private. Could be. Oh, wait. Declare public properties. Click there.
Declare where?
There's a link there. Property attributes are specified inside parentheses after the blah blah blah, and are described fully in this describe declare public property. Can
Look
you
at the documentation we are reading.
can you remove the underscore of the first and see if it decreases one error?
Oh, oh, that's actually a good call.
On the registers, I don't know, anywhere. Just remove one. I'll check the error messages as of now for changing everything.
Okay, so the first arrow pops up, line 8. Yes, which is the one that we just changed. And now the first arrow pops up, yeah, line 8.
So
Use of
this still
undeclared.
doesn't know how to get the registers.
I want to check. I want to see how he is managing the
I don't
last
think he's
first
using
name.
attributes, is he?
He is. Oh, self.
Oh man, you gotta be kidding me. Yeah. Oh, that's just
Oh, that makes more sense, huh?
yeah, it makes sense because just cringe.
Okay. Where does the first arrow pops up? Line 9.
60.
Line 9.
Wait, 9.
RAM not found. Do you have RAM? Uh,
We need to buy
RAM. Oh,
hardware.
no, we don't have RAM.
It's memory RAM.
That's
Oh yeah,
related to
RAM was
RAM,
an argument, right?
otherwise.
How is this?
Yeah.
How is this
No,
compiling?
because RAM was an argument, so
Oh,
the
you
name was
changed
different.
it. Ah,
Yeah,
fuck.
yeah.
I thought you would just use the same names, man.
No.
Okay, so, oh well. Let's do a replace string
And I hope you don't
RAM.
replace something different.
I hope as well.
It's all caps, by the way. RAM.
Ah, how cool.
I have a question for present Lemos.
Go.
Are you annoyed at past Lemos for naming the thing memory RAM?
No, it's fine. Oh, it
Yeah,
worked.
so
It
it
worked.
worked. As my dad would say, maledetto. That's literally that.
Okay, so now it's just a slavery
Why
job.
don't you pick all underscores and
Because
just do it?
because I don't know if we have more than.
Well, if we do, we shouldn't.
Okay.
We don't. Okay,
41.
so let's see.
Okay. It
Okay, now
worked.
it's an even more bizarre error.
No.
It's
This
a
is implicit
linker problem.
declaration of function. This is correct.
No,
It
yeah, but
worked.
check all the way down. It
What?
didn't.
Okay,
Error.
so
No, go back. There's still an error.
where?
Linker.
Linker
Look.
command
Yeah, of
failed.
course the linker is wrong. It didn't find this
Okay, but why?
because I changed it.
You changed what?
I changed the names.
Oh, you kidding me?
No. Ah. Oh, this is the typical job I would let you do it, Magita, but I'm gonna do it for you.
Oh no, I wouldn't do this. You know what I would do, right? The parsing. Of course, I would do
No,
that.
but the parsing is easy, man.
By the
Yeah,
way,
just for the meme, man. It's just for the suffering.
if
Go.
you look at the syntax of the thing I'm writing, you will probably be okay with parsing it because
Uh,
it's not.
just one thing here, Lemos. Since all of them actually do the same, can't you just do a macro to do it?
Teach me.
So let's test in one of them first. So go to line 283. So yeah, so put your cursor there and
Oh no, but
press
not all of them have only 2 spaces. Some of them have 3.
Okay, but that doesn't matter.
Okay then.
So press Ctrl X and then Shift 9. There. So now delete this. And then now select this
MC.
character.
MC.
Select the character. Wait. Yes. Now meta X. And I think there's a function called uppercase. Let me see. Wait. Emacs char to
That's MC,
uppercase.
man. But okay, MC is to
Yes,
capitalize a
okay.
word.
Okay, just do it then.
No, but I don't know if it's gonna capitalize it correctly. Let's just find a function.
Okay, just capitalize it then.
Is this the one? What's the name of the
Oh,
function?
you don't know if it's uppercase.
Yeah, I
Wait.
don't know.
Well, type MC, press. I think if you press Ctrl. Mm,
Let's close the
oh, it
macro and
is.
try again.
I know, it's uppercase. Uppercase.
Uppercase like this?
Mm-hmm.
Uppercase what? I
Press
pressed enter.
tab. Press tab.
Char?
Char. There. There.
It did in the O in the P, not in the O.
Oh man. Oh, it's where your cursor is.
Yeah,
Oh,
but I selected the O.
press Ctrl X U. Now go back to. Then press do the same thing again. Uppercase char. Okay. Now Ctrl X. And then Shift 0. Okay. Now what you're gonna do is place your cursor in the there and press Ctrl X E, like E, like there we go.
Oh.
Now
Okay,
you
so
just
I
need
can
to
can I
repeat the
just
same.
select
Yes, all of them and do the
Yeah,
same.
but I lost my shortcuts to select all of them.
Just press Ctrl and then Shift dot on my keyboard, which is the angle brackets to the right, like greater than. Yes.
Oh, that's wrong. Oh, it's gonna do more than enough, man.
Oh yes. So you're cursed. I mean, it's still more efficient to just go pressing Ctrl E, right? But
What? So Ctrl X E. And it didn't work in two cursors.
you need to put it one before. Yes. Yes, there.
Well, I mean that's faster, but still a lot of work anyway. Oops.
You gotta suffer a little bit.
And that's shortcut position for the fingers is terrible as well. It's hurting my hand.
Well, that's even greater. Oh, star. By the way, I
What?
forgot the star. I forgot the star. 295.
295. Oh. Okay, cool. Thank you. What? What the heck happened?
Right variable instruction.
I didn't
Keep
do
that
anything.
Q.
Q.
Q. Yeah.
I didn't do anything.
Well, Emacs
Something
felt
blew
something.
up. Let's ignore it.
Emacs felt something.
Again.
I think you're pressing the debugger. I think it's around that. My hand mispressed the key.
Imagine if this works, man. How crazy. Ah. Again.
That's your problem, man. Back.
Oops. There. Okay, is this it?
I think so. I hope.
I definitely hope. Okay, I'm actually gonna YOLO it.
I wouldn't
Okay,
call that
something is
yellow.
wrong. Instruction OP load A undefined reference. So it didn't find the reference.
Are the names right? I don't remember seeing those weird names.
It's I just switched sneak case to camel case because we are already using camel case.
Are you sure that on the implementation they're like that?
Yes, I am 100% positive and I can demonstrate. Here.
They are.
Instruction OP fetch. Instruction OP fetch.
And on the
Oh,
.h
of
as well.
course! This is not a function. We need a macro. We definitely need a macro.
Oh right, that's true.
Oh well,
Yes.
I can actually try to.
Yeah, search by instruction, like dual multiple cursor. Yes.
I have a request.
Go.
Can we rename the fetch instruction to
Control A.
literal?
Wait, just a sec. No! What did it do?
That's
What
right.
did it do, Ramos?
That's
Oh
right.
yeah, you don't need anymore. That's true.
Magete was.
Oh man. I was
Why
just
this didn't
afraid.
work, I have no idea.
Yeah. What were you saying, Maria?
Can we rename the fetch instruction to lit or literal?
To lead to fetch a literal.
Yes, it fetches a literal, but there's already the PC fetch, and the names are too similar.
Okay, that's a good suggestion. Ooh! Oh, 12! It worked! The categories thing worked!
Magic. Complete
Oh
magic.
boy! I can't believe it. This is cool. This is very cool. So what the heck we gonna call it? By the way. Opcode.thing. So instead of op fetch, you want op lit, right?
Yeah,
Let's do literal.
Yeah, we're not
sure, that
saving
works.
bytes here, right?
That
Not well,
works.
we are, but not that hardcore.
Yeah, not those bytes. Yes.
Oops. Oh, I should save this first. Yeah. Okay, so we want to go to here. We don't have a fetch anymore. We have a literal. Question, is that it?
Rename the function opfetch.
Oh yeah,
Or should I say the method?
the methods. You should say the methods. I actually want to do a little bit more of well, I'm gonna commit this for sure.
We try to run the code real quick. Just make sure we didn't forget to rename anything.
Yes.
What do you mean? The code works. I just ran it.
Yeah,
No,
but
I
you
mean
renamed
you
the
just
expression.
renamed an instruction, right?
Oh, I need
Just
to rename the fetches that we have in the example.
X as
Uh,
well, yeah.
okay, so let me
Uh,
select this. Magenta, we are using
yeah,
categories. Categories, man.
Aristotelian categories.
Probably not that fancy. So what did they call the literal?
Literal.
literal, yeah.
Yeah.
Okay. Let's see.
That's better. That's
Let's
much
see
better.
if it works. It does.
Okay, it still works.
Okay, Ctrl
Now please
XG.
commit this.
Yes, I will
I'm
commit.
scared. I'm scared of what
Uh,
will happen.
so yeah, this file is gone. Actually, we don't know which imports are actually necessary because I'm not gonna touch them.
Don't
Uh,
just commit and then we check on the PR.
okay, so this. How do I remove? How do I delete?
K.
Okay,
Yes.
yes, thank you very much. That
And just press S on everything.
I don't like to do that. You know that.
Yeah, you already saw, man. Like
No, yeah, no, but I do
and
like to do
everything
proper
is working there.
commits.
Proper commits.
Yes. So this is changing
Oh, using
instruction
category.
functions to be a separate category. How cool. Um, um, wait, what? How I
Uh,
can't commit?
Ctrl G.
It's actually not showing which branch I am.
Press LL. What?
I press LL.
Oh no, wait. Ctrl G. Ctrl X G.
Mm-hmm.
Okay, so you are in Magit.
Yes.
Press Tab.
Oh, you
So your
want
commit
this?
is there. So press
Capital P, right?
Ctrl G. Press P. Lowercase p.
Lowercase.
Just P. Are
No
you
previous
pressing?
section.
Okay. I think no. I think it's uppercase, right? To push.
Yeah, but it's not showing push. It's just saying another branch, matching branches.
Well, try type B.
B.
Yeah, the B is the branch. Oh, Ctrl G. You need to quit all of this. B. And then local branch. Yeah.
This is the one,
So
right?
where were you?
I was in here all the time.
Oh, but that's on origin. Are you sure?
Yes, I was here all the time.
Because it says okay. Do tab there on this commit. Oh
I lost.
What did you do?
I lost stuff.
No, you didn't.
I
Just
know I
go back
did.
to the.
Yeah. Okay, go.
So press B again, L, and go to master. It's not there. What the heck?
Did I
Press
just
B,
lose 2 hours of my life?
press
What are
B,
you looking
L
for?
again. Oh, have the recording at least. B, L again.
Ah,
Stack manipulation. Man, where the heck did you commit that?
I was. We can show
It
in the
was
recording.
out of a head, man. Did you see that it was showing like the head
Yeah,
where
it
you
was.
committed?
I understand it was, but I can assure you in the recording I was just I was in add arithmetic blah blah blah.
Okay, let's see. So press B again. L. So you only have origin, which if it's origin, by the way, that means that you don't have a reference. So that's not where you should have committed, and that's not where you can commit. Otherwise, it would show just without the origin.
Let's just
So
try
it
to find
should.
the commits and then I can just make another branch, man. Who cares?
We can do git checkout on the commit and cherry pick. Oh man, can you stop the recording?
Sure.
So I have a strategy that I had